join the center of these two circles. This is r root 2. This length is the radius of the smaller circle r, and this is nothing but the radius of the bigger circle, which is given to us as 2 centimeter. So now can I say that this length is 2 centimeter because it is the radius and this angle is 90 degree. This length is also 2 centimeter and this angle is 90 degree. So now this is 2, this is also going to be 2 because these two sides are always equal, just like in this case. So this is 2, this is 2, so this length is nothing but 2 root 2. So if this length is 2 root 2, straight away I can say that is r root 2, this length plus r plus 2, this particular length is equal to 2 root 2. And from here on solving this, we can easily find out what is the value of r in this case. Let's take another example here. This is a rectangle of dimension 9 by 12. Width is 12 and length is 12 and the width is 9 here. If I draw two circles inside this rectangle, let's say I draw two circles inside this rectangle. Now, and the radius of both the circles are same. The radius of both the circles are same. So if the radius of both the circles is same, I need to find out what is the radius of these two circles. Now, just see how we can find out here. Now, can I say this length is r, radius r. This, let's say the center of this circle is this one, this is also r. So if this is r, and if I draw a line, if I join these two centers, let's say this is O and O dash. Now, so this is r, so I can say this length is equal to 2r, the distance between the center of these two circles because they are touching each other. So this total length is 2r, but since this is r, so what about this particular length? If this length is r, यहाँ से यहाँ भी क्या होगा r. From here to here it is r, from here to here it is r, and total is 9. So can I say this length is nothing but which is 9 minus 2r. And this angle is 90 degrees. Draw a line which is parallel to this particular line. So this angle is 9 minus 2r. Similarly, if I say this one, this is r and this is also r because radius and radius. So r and r. So this is also r, if this is r, this is also r. So r from here and r from here. So can I say this length is nothing but which is equal to 12 minus 2r if I neglect r from here and r from here. So this length is 12 minus 2r. Now again apply the Pythagoras theorem for this triangle, which is 12 minus 2r whole square plus 9 minus 2r whole square is equal to 2r whole square. And now again by solving this equation, we can find out what is the value of r. So even if you look at all the last three equations, we are applying the same funda here. Now, let's say if I say there are two circles. These are two circular wheels. These are two circular wheels, and these two circular wheels are connected with the help of the rope. Let's say the rope is something like this one. And we need to find out what is the shortest possible length of this rope. This solid part is my rope here. And it has been given to us that the radius of this circle is 6 centimeter and the radius of this circle is 18 centimeter. Now just say how we can find out the length, this entire length here, entire length of the rope. If this is 6, this is 18, and since this acts as a tangent, so let's say these angles are 90 degree. Now we can definitely find out the length of these two. This is because this is nothing but the direct common tangent from here to here, and we know that the length of the direct common tangent is equal to under root of distance between the center if I join these two center, okay, which is O and O dash. So which is d square plus r1 minus r2 ka whole square. D square minus r1 minus r2 ka whole square. So from here we can find out the length of direct common tangent. So this tangent and this tangent, these two lengths can be find out. Now we are supposed to find out what is the length of this particular arc, which is important here. This particular arc. So just see how we can find out the length of this particular arc here. Now what I can say here in this particular case, if this is 6, draw a line which is parallel to the length of the direct common tangent here. So if I draw a line which is parallel to the length of direct common tangent in this way. So if this is 6, this length is again going to be equal to 6. So this length is nothing but 18 minus 6, which is 12. Now we get this as a 12, and what is this total length? This total length is nothing but this one. If I say this is 6 and this is 6 here, and this radius is 18. So this total length is 24. So this is 24, this is 12, and this is my 90 degree because I had drawn a line which is parallel to these two lines. These two lines are parallel. So this is 24, this is 12, and since this is the half of this one, so straight away I can say that this angle is 60 degree. Because sin 60 is equal to what? Half. So 12 by 24, which is half. So this angle is 60 degree. So once I get that this angle is 60 degree, similarly on the other side, we can also say that this angle is also 60 degree by using the same logic. So if this is 60, this is 60, this total angle, this particular angle is 240. Now once we find that this angle is equal to 240, can we find out the length of this arc? Yes. The length of this arc is nothing but 240 divided by 360 into 2 pi r. And we know what is the value of r, which is 18. So we can easily find out what is the length of this particular arc here. With the same logic, since we had found out this angle is 60, so join these one. So this angle is also 120 because this total angle is 120, so this has to be 120. Both the figures are similar. So this is 120. So once we find out that this angle is 120, we can also find out the length of this arc. Now how we can find out the length of this arc? Again the same funda, which is 120 by 360 into 2 pi r. But here the radius is 6. So we can find out the length of this arc, which is 120 by 360 into 2 pi r. We can also find out the length of this arc. We had already found out what is the length of direct common tangent, this tangent and this tangent here. So we can find out what is the shortest possible length of this particular rope here in this case. Now let's move to next thing, that is the mensuration here. Because once you discuss the circles, after that, yes, simply take a couple of examples from the class exercises. And mensuration will start with the first of all the two-dimensional figure, and then we'll gradually move to the three-dimensional figure. So in two-dimensional figure, we'll start with the first thing, that is quadrilateral. Now what happens in case of quadrilateral is nothing but any four-sided figure is a quadrilateral. Now the thing is how to find out its area. So the area of the quadrilateral, for example, if I join this diagonal, if I draw this line which is perpendicular, let's say D1, and this has another perpendicular, let's say P1 and P2, and let's say the length of this diagonal is D. So the area of the quadrilateral